All right, so here we are finishing up chapter 1. Here's section 1.2, sampling errors and bias. And I kind of said in the last video I wasn't going to read everything to you, and then I sat there and read everything to you, and the video turned out to be a lot longer than I meant it to be. So I'm going to stop reading so much. I'm going to let you read through these these definitions right here. And if you haven't, just go ahead and pause the video, read through those first 4, and come back after you have read them. Okay, so we are talking about sampling errors, non-sampling errors, and bias. Again, we are just going to kind of dip our toes into all of these vocabulary words, and then we are going to really hit this again in a second, or I guess now third video. I'll be wearing different clothes though, because I'm going to do it on a different day. Okay, so first question. Do you prefer McDonald's like most people or KFC? Is a sampling error or not? And so what we're doing here is we're looking at the kind of question that is listed here. And so this is sampling error because, I'm sorry, this is a non-sampling error because sampling error just kind of happens, there's going to be error. Nothing's perfect. Non-sampling error is things that you could actually have avoided. So a poorly worded question, which we saw right here under non-sampling errors, that would be this example because it's quite biased question. Like when you say, do you prefer McDonald's like most people? It kind of makes you want to say, yeah, I do like McDonald's because I want to be like everybody else, so it kind of gives you that bias in the question. So this is a non-sampling error. Okay, so again, sampling error is when, just things that happen that we can't control. The smaller the sample, the more likely the more room there is for error. But non-sampling errors you can control, and those are the things you should be looking out for when you're doing a survey. Number 2, it says 2 researchers created an online poll to find out which of the 2 candidates for city mayor is preferred before voting. They later realized that 45% of the sample size included non-registered voters. So it says, it's what kind of error is this? And so this would be a sampling error because the error, we don't know what the question is. So we don't know that it was a poorly worded question. But it is a problem where you asked the sample to join, or sorry, you had people do this survey, and then there's a problem with the sample. So again, it's not the size that's the problem. It's the fact that the sample included people that aren't even eligible to vote, and that, in theory, we don't really care about their opinions because they're not casting their vote. What's a non-registered voter? I guess it could be a 16-year-old. It could be someone who's moved to a new state and hasn't registered to vote. It could be someone who doesn't believe in voting, I guess, if that's the right wording. Someone who doesn't have their license, probably or possibly hasn't registered to vote, because you typically get your driver license and register to vote at the same time. So we have an error. The sample is the error right there. Okay, misleading statistics. So again, go ahead and pause it and read through that. If we were in class, I would just go take attendance while you were reading through it, but what am I going to do now? Talk to my dog? I'll probably still talk to my dog, but go ahead and pause it, read through that, and then jump back in when you're ready, and just keep going. So it says the math professor teaches 2 sections, we'll just call them A and B, of Calculus 3. So section A averages 35 students and section B averages 15 students. Section A has more volunteers to mentor high school students compared to section B. Okay, what is the problem with this logic? Well, so this would be misleading. The way this is explained, we're going to say misleading. And the reason why, or the problem with this logic, is I'm just gonna make a sample chart here. So I have A and B. I have 35 students and I have 15 students. Okay, how many volunteers? Let's just make up a number. Let's say not even half of the people in A volunteer. Let's say only 16 people out of the 35 volunteer, less than half of them. Well, that's still more than B. B can only have at most 15. So with this logic, we're saying A has more volunteers. It's true, but it's misleading because it makes it sound like A is like the more altruistic class. They're more generous with their time, this, that, and the other. But if you look at the data, we see that less than half of section A is volunteering, whereas 100% of section B is volunteering. They just didn't have as many people. So that's the problem. I kind of explained it with a little chart instead of words because I was running out of space. But, you know, this first chapter is kind of like, don't believe everything you read kind of chapter, like kind of introducing you to statistics just so you can see how misleading they can be. Or, you know, like we see up above, it's inaccurate or not complete or not correctly displayed. All right, number 4, we have an apple farmer. And he wants to know how many bruised apples he has in each box out of the 300 boxes he has. So he lifts the lids of 5 boxes and examines the apples on top. Is this biased or unbiased? And I'm going to add why. Because most people, their gut feeling is to say bias. And that is true, yes. The problem is, why did you say that? Now, some people will say, because 5 is too small. That is not the answer, because I told you in the last video, we're not judging these things based on size. We have no definition of sample size. We have no explanation of what a good sample size looks like. Some people just think if there's 300 boxes, 5 is too small. Okay. I can't help you with that other than to say, quit it, because that's not how we judge things. The problem with this is the on top part. He's the apples on top. He could choose 5 boxes and do cluster sampling, and he could look at every single apple in just those 5 boxes, and I would say, yes, that's fine. Or he could choose 5 apples randomly from every box. That's fine too. But if he's only looking at the ones on top, they might be bruised differently. Maybe the ones in the middle are better insulated because they're getting by the others, or maybe the ones on bottom are actually more bruised than the top ones. Who knows? So it is biased, but what he needs to do is he needs to look at all apples in those 5 boxes. So it's fine that he only chose 5. It's not fine that he only chose the apples on top. All right, next video. So we have 1.2b. This is actually the end of chapter 1, so it's kind of a good thing because chapter 1 is very tedious on vocabulary. It's not going to be like this. Like chapter 2 is like almost all numbers, so it'll get better. But chapter 1.2b, variables and measures of data. So we talked about 2 types of studies, observational and experimental. And so those 2, no, not those 2, but observational specifically, observational study is what we are talking about here when we have the explanatory and the response variable. So the explanatory, it's like you do to people. What were we talking about last time? Like if we had this group jump ropes and this other group runs, that would be the explanatory variable, or you could call it the treatment, is what we're doing to the people. And the response is like the why, it's how they respond to that explanatory variable. Maybe their heart rate went up. maybe their blood started flowing faster. Whatever their response is, that is, oh, that's the response. Look at that, how clever. Okay, so explanatory is the X, that's the input. Response is the response, that's the Y, and the output. And these only work for observational studies. These do not work for, oh my gosh, I totally said that wrong. Are you yelling at me yet? You're going to do that a lot, I know. Because in class, you would just raise your hand and be like, what? That doesn't make sense. Why was an experiment? I thought you said experiment is what we do. Experiment. Yep, experimental. Okay. So here we go. You want to know if there's a relationship between the amount of time an employee spends in training and the amount of time he or she emails their manager. So we want to know what's the explanatory and what's the response. Well, what can the manager control versus what is the employee's response? So the manager can control the time of the amount of time training. So that would be the explanatory. And then the response of the employee is the amount of time that they email. So explanatory is what the person doing the study can control or what they do to the groups. And then the response is what the people, the subjects are responding to. That would be the data that we would be collecting. Okay, manager wants to know if cold brew, AKA my favorite, coffee production before lunchtime. Cold days, he brews just regular coffee. So it says up here, cold brew has a higher concentration of caffeine. When the cold brew was brewed, there was more production at his manufacturing plant before lunchtime. Give 3 examples of lurking variables. So a lurking variable is like it's lurking, it's hiding in there. It's an alternate explanation. So maybe, oops, that's supposed to be an L. I made it a T. Okay, well, it's just a mess. Alternate explanation. So maybe the coffee is affecting people, but maybe there is another reason as well. And we always want to think about those lurking variables or those alternate explanation. And so some things to consider. I'm that person right now because I really like to know what people say here because people always come up with such clever examples on this one. But let's see. Do they like the taste? That's one variable. Maybe they like the taste of one over the other. And so that would actually affect the study. If you only like one of these, then you're only going to drink one. And then you don't really know if the coffee is affecting or not because you only drink one kind of coffee. What's the temperature? If it's 100 bazillion degrees outside, sounds familiar. Maybe you kind of just want to drink the cold coffee and you're not going to drink the hot coffee. Whereas in the winter, maybe the opposite is true. Maybe you'll only drink the hot coffee, or maybe you love coffee all year round. Doesn't matter if it's cold outside, you just want the cold brew. Another reason says to give 3, so I'll come up with some. If you come up with a different one, don't worry about it. That's perfect. That's what I want. I'd rather you come up with different ones because it gives me, so then I know that you're thinking about this too. But another reason is like, who's at work? And what I mean by that is, it says for 5 days he did this, and the next 5 days he did that. Well, are we talking about this Monday through Friday versus that Monday through Friday? Or are we talking about 5 days, 5 weekdays, and then the next 5 days include a weekend or holiday or something? So maybe it's completely different employees that we're talking about. But this is all the same time of day because it's before lunch, right? Yeah, before lunchtime. So it's all the same time of day, but we don't know what days it is. So who's at work, what days could could also be affecting this. So it could be that the cold brew is better to help them, makes them work more because of the caffeine. But it could also be no one's drinking the hot coffee. It could also be different people are at work, so why are we comparing apples and oranges? So there's other variables in there, hidden, lurking, if you will. So that's what we're looking at for example 2. Okay, lots more vocabulary. So I thought this was the last one, but there's one more after this. Okay, so we have 4 scales. And what I want you to do is write down everything I say and keep this handy, because on the homework, you're going to be asked to go back and forth between these different scales. And when you see the examples, you'll be like, oh, this is super easy. I can totally tell which is which. But if you're just trying to remember which is which, it gets hard. Okay, so we have, and I talked about this briefly in the last video, we have categories and like words, and then we have numbers. So these 2 are going to be categorical. Categorical, oh goodness. Categorical, and these 2 are going to be numerical. In other words, the top is going to be words. The top 2 are going to be words, and the bottom 2 are going to, well, I don't need to write it out. The bottom 2 are going to be numbers. Okay, so nominal data that is measured using this as qualitative, that means words, but not ordered. Versus ordinal, it can be ordered. So first off, think of words that don't tell you what order they're in. So I could start off by just listing colors. Colors are words, but they don't really mean anything. Like if I say purple, red, blue, orange. Okay, put those in order. What kind of order? That doesn't really make any sense. So they're words that can describe things, but you can't really put them in order. What's another one like? Oh, we're gonna do that one. I don't want to do that one. Words, no particular order. I'm trying to think of another set of words. Okay, so we'll come back if we think of more. But ordinal is going to be words that can be ordered. So, for example, so when I say color, let me come back to colors, because I'm about to use colors and I'm about to order them, and you'll be like, oh, what? So if I just use, I don't remember what I said, purple, red, yellow. Oh, I got a great example. Remember kindergarten? Remember when your teacher would be like, okay, you're in the red group and you're going to work with me. These other people are in the purple group and they're going to work by themselves. And you kind of knew like who was the smart kids and who needed extra help. But technically, there wasn't really an order attached to it. It was just colors. Let me tell you some other colors and you will be able to put these in order. Silver, gold, bronze. Those are words. You know, as soon as I said that, you know which one is first, which one is second, and which one is third. So those are words that can be ordered. So what did I say? Gold, silver, and bronze. There's lots of words that can be ordered. For example, I want you to fill out this survey from completely satisfied to completely dissatisfied. So again, there's a ranking, medium satisfied, neither, medium dissatisfied, completely dissatisfied. There's a ranking there, and satisfactory. All those words, they mean something in terms of an order. Other words like purple, red, and yellow don't really mean anything in any particular order, but you can group things that way. All right, interval scale, data that is measured has a definite order, and the difference can be measured. However, the data does not have a starting point. So that would be like temperature. So temperature, that has an order, that's in numbers, and the difference can be measured, but let's see, 30, if we're in Fahrenheit, -10. So you can tell which days are hotter and which days are colder if I use that scale right there. But there's really not like a lowest temperature. because, you know, put it in a freezer, add dry, I don't know, do some chemistry stuff to it, make it colder. Same thing with temperature of hotness. I'm not talking about put a thermometer in your mouth, you know, that's going to end at some point, but how hot is this fire? How hot does it to melt metal? I don't know. It keeps getting hotter and hotter and hotter. So there's no starting point. It goes the middle, hot, cold. There's no start. So that's an example. It has numbers. I could tell you the difference between 32 degrees and negative 10 degrees. That's 42 is the difference. But it doesn't really start at a certain spot. Whereas the ratio scale level, I'm just going to write heights. Heights is an example of a ratio scale because it has a starting point. There's a lowest height. Think of about a baby being born, like I'll just make up a number, 18 inches. There's no baby that's negative 2 inches. There's a starting point at which people have a height. And then, especially if you're talking about grown-up heights, well, grown-ups typically report their height in inches in America, meaning I am 5'6". You ask my son how tall he is, he would say he's 5'1/4" because he's a kid and he imagines he has that quarter in there. Same thing with ages. How old am I? I'm 41. I'm not 41 and a half, right? Because I'm a grown-up. But little kids, they have the halves. And so the ratio scale, I guess ages, that's another good one. It typically has whole numbers, not decimals. Whereas the interval scale, it's kind of that sliding. How hot is it outside? Oh, well, you know, what's your temperature? 98.6. We could have decimals in temperature. So, all right, have I talked about that box enough? I hope I talked about it enough for you to be successful in your homework, but we'll do a couple more examples in another video. All right, number 3. Ask them a question. The answers are Twitter, Facebook, Instagram, Snapchat. What scale is this? So it's words, so it's one of the top 2, but it is words that don't mean anything. Twitter does not mean a number. Facebook does not mean best. Instagram does not mean worst. Now you can have an opinion on which one you think is best, but it's not universal. So this would be a nominal scale. All right, manager gave a test. So we can see right here that there's numbers involved. Which scale is this going to be? And so we are going to say ratio because there's not a decimal, but more specifically, there's a starting point. You might get a 0 on the test, but you're never going to get a negative on the test. There's some starting point for this test and an ending point. All right, just when you thought I couldn't talk anymore, 4 more words, but this will be it. Okay, so we have qualitative and, oh yeah, I did spell it. No, I spelled it wrong here. Quantitative, quantitative. These 2 are from this one. So the quantitative will be split up into 2 categories. I told you when I make the same typo, I repeat it. So qualitative, those are words. Words or letters. That would be the top 2, the nominal and the ordinal that we just talked about. Quantitative are numbers. They're the result of counting or measuring. So counting or discrete is counting, continuous is measuring. And I'm going to give you one example with both of those in it. Qualitative is easy because it's just words, so that's it. It's its own category. Quantitative has 2 subsets, counting and measuring. So if I said, how many books are in your backpack? You're going to go look at your backpack and you're going to count how many books are in there. How many books are in your library? How many books are in your trash because you got frustrated and threw them away? I don't know. How many books is a question where you would count. But if I said, how much does that backpack weigh? That is continuous because that is a result of measuring. So when you count, you have whole numbers and you count them. You know what counting is. When you have continuous, you are measuring. So you're going to use a ruler or a scale or some sort of measuring device. Okay, so here we have just two examples of the quantitative, because like I said, qualitative is words. So that's the only thing. If you see words, it's qualitative. Here we have numbers. So we know this is quantitative, and the question is, are they quantitative discrete or quantitative continuous? So he tallies the number of calls he makes each week. You know what a tally is? Like made a call, 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 made a call. That's just counting. So that would be discrete. He was counting. All right, next one, he tallies the mean. We'll get this in the next chapter, but that means average. The average number of calls he makes each month for an entire year. So we're no longer counting, we're taking the average of each month. And so this is going to be, I blocked it up. It's in a separate line, quantitative continuous, because he measured, oh my goodness. It's getting late. Can you tell? Measured. In this case, used formula. So I said a minute ago that you could use a scale or a measuring tape or something, but you can use a formula too. You calculate it. That would be some sort of measuring. Counting is just like to my camera. 1, 2, 3, 4. You know, that's counting. Anything else where you use a tool, and a calculator is a tool, then you are doing measuring. All right, clearly it is past my bedtime, so I am going to stop here. That is the end of chapter 1. Next chapter will be a lot more numbers, yay! But we will be doing a review of chapter 1 before we get there. So don't worry, there's lots more vocabulary practice coming soon. All right, see you in the next video.